Let's take a look at Avogadro's constant. We must first consider the term amounts of substance. This is a quantity of something. The word couple, for example, refers to two things, whether that be two people, chocolate bars, or atoms. The term dozen refers to 12. So if I have a dozen donuts, I know I've got 12 donuts. A million translates to 1 times 10 to the power of 6, or could also be written as 1 followed by 6 zeros. A mole, like any of the other amounts of substance that we've looked at, is just a numerical value. The number associated with a mole is 6.022 times 10 to the 23, which is also known as Avogadro's constant. What's particularly challenging about Avogadro's constant is the scale of it. To give you a better idea, it's predicted that there's more than 1 mole of stars in the universe. That's not even in the observable universe, but in the universe altogether. That's more than 6.022 times 10 to the 23 stars in the universe in its entirety. That's a huge value and a number that we just can't comprehend. Let's work through some questions related to amounts of substance. So in this one, each tray contains a dozen donuts. How many donuts are present in 5 trays? From this question, we can immediately tell that 1 tray equals 12 donuts. If we have 5 trays, we have 5 times the amount of trays. That's the equivalent of 5 times the amount of donuts. Therefore, meaning we've got 60 donuts in 5 trays. Now let's take a look at this question. A sample of magnesium contains 2.5 moles. How many magnesium atoms are present in the sample? Let's quickly just replace the word moles for dozen. We would solve this by identifying the amount of dozen. In this case, it's 2.5. We then multiply that by the number of atoms that are in a dozen. So we get the calculation 2.5 times 12, which is 30 atoms. Now let's repeat the process, but replace the word dozen with moles. Well, we still have 2.5 moles. So we take 2.5 and we multiply that by the amount of atoms in a mole, 6.022 times 10 to the 23, Avogadro's constant. That equals 1.51 times 10 to the 24 magnesium atoms. All we have done is taken the moles, multiplied it by Avogadro's constant, the amount in a mole, and that gives us the amount of substance. Looking at another example, calculate the number of atoms present in 0.2 moles of water. We not only need to consider the amount of atoms in a mole, but we also need to look at the amount of atoms in a water molecule itself. We can start off by writing out the equation. Moles times Avogadro's constant equals the amount of substance. Let's start by filling in the information we know. 0.2 moles of water multiplied by Avogadro's constant, 6.022 times 10 to the 23, which we can give the units moles to the minus 1. That's because there are 6.022 times 10 to the 23 things in a mole. So that's why we can use moles to the minus 1. And then by using a calculator or in your head, if you're very good with mental maths, calculate it, and that should equal 1.2 times 10 to the 23 water molecules. Now, for every water molecule, there is 1 oxygen atom and 2 hydrogen atoms, so 3 atoms in total. We therefore need to multiply the number of water molecules by the number of atoms in each molecule, leaving us with 1.2 times 10 to the 23 molecules multiplied by 3 atoms, which equals 3.61 times 10 to the 23 atoms. We have now solved this calculation. The final question we're going to look at is a little more complex, but we can follow exactly the same process. So firstly, reading the question. Ethane is a fuel and completely combusts when heated in the presence of oxygen. We've been given what is a balanced equation, so we don't need to worry about that. And 0.66 grams of ethane completely combusts. Determine the number of molecules of carbon dioxide that reacted. I think that should actually be that were formed. We have information about ethane and we are looking for carbon dioxide, so these are the only two parts of the equation we are interested in and may as well highlight them. The first rule of solving this calculation is finding the moles. We have the mass, and using the triangle, mass divided by mR equals moles, we know we're going to have to divide the mass of ethane by its molecular mass, which is 30 grams per mole. The units of mR are worth noting because as you progress in calculations, following the units is a useful way to make sure you're performing the right calculation. In this case, we can cancel the grams, and 1 over moles to the minus 1 is moles, leaving us with 0.022 moles of ethane. Looking at the ratio of ethane to carbon dioxide from our equation, it's a 1:2 ratio. We therefore need to multiply the moles of ethane by 2 to get the moles of carbon dioxide, which would give us 0.044 moles of carbon dioxide. Now we have the moles of carbon dioxide, we simply have to multiply it by Avogadro's constant, 6.022 times 10 to the 23, and that gives us the number of carbon dioxide molecules formed in this reaction. If you've enjoyed this video and found it useful, please like, share and subscribe to the channel.